Hi everyone. In this video, we're going to be doing A-level further maths 9231 paper 12, October, November 2025, further pure maths 1. This paper is 2 hours long and I do offer tutoring services as well. So if you want to know more, skip to the end of the video and please click the link in the description box below. So with that settled, let's get started with the first question. Okay, so for the first question, sorry. Okay, sorry for the delay. So, for the first question, we're told to use standard results from our MF19 to find this summation in terms of n. And the last part, very important, we have to fully factorize our answer. All right, so this is a very simple classic question that you must know how to do. So, let's copy everything down. And now let's split this whole summation into two separate summations. So you just split them up, just like you know how you do integration and differentiation of sums, right? So we have the summation of r cubed minus the summation of r, both of them from r equals to 1 all the way to n. Okay, so now we can start using the standard results for R cubed and R. So you go to your MF19 all the way to further pure maths. Yeah, so you can see it's the very first section. Sorry. Yeah, you can see you have all your summations here. So we're interested in this and this. So for R cubed is 1 over 4 n squared times n plus 1 squared. Okay, so 1 over 4 n squared times n plus 1 squared. Yep. Okay, and then for r, it's just half n times n plus 1. Okay, all right. So now we can start factorizing this expression. So right off the bat, I can see that we can factor out 1 over 4 from both expressions as well as n and n plus 1. So let's factor out 1 over 4 times n and n plus 1. So for the first expression, you would have n times n plus 1 left. And for the second one, half n times n plus 1, you would have half divided by 1 over 4, which I believe is just 2. Yeah, it's just 2. Okay, let's expand this slightly factorized quadratic expression. Okay, so n times n is n squared, n times 1, that's plus n minus 2. Okay, let's see if we can factorize this quadratic equation. So just try to solve it using a calculator. Okay, so we can solve it. Basically, we have rational solutions. So the factors are n minus 1 times, uh, oh, wait, what? And n minus 1 times n plus 2. Yeah, so I believe we can stop here. It's fully factorized. You cannot factorize this anymore. So yeah, this would be our final answer for the first part. Let's move on to the next part. Wait, let's see. Yep, you can combine, yeah, there's no duplicates. So yeah, we can move on. Okay, so for the next part, we are told to express this rational function in this form. So basically, we have to express this in partial fractions and split it up into partial fractions, basically, right? And then hence, using our result that we get here, we need to use the method of differences to find this summation, where r is equals to 2, all the way to n. So yeah, just be careful it's not r equals to 1. Okay, so first part, we need to split it up into partial fractions and express it. Okay, so r plus 3 over, so let's factorize this denominator. So right off the bat, we can factorize out r. So we have r times r square minus 1. And this r square minus 1, we can just rewrite as r square minus 1 squared. And we can use the differences of squares to factorize it further. So using that, we will get r times r plus 1. Okay, r plus 1 times r minus 1. Okay, all right. So now we're ready to express this in partial fractions. So luckily for us, they already gave you the form which you're supposed to decompose this in. All right, so it's a minus over r minus 1 plus b over r plus c over r plus 1. Okay, so to get started, just use your do the usual procedure when you're decomposing any rational function into partial fractions. So multiply both sides by the denominator. And yeah, so for a, the r minus 1 will cancel out. So you would have a times r plus 1, not r minus 1. Yeah, a times r plus 1. And then for b, your r will cancel out. Then you would have r plus 1 times r minus 1. And then for c, your r plus 1 will cancel out, so you'll have r and r minus 1. So c times r minus 1. Okay, so now to solve this, to find the constants, the way we do this is to make one of the factors equals to 0. So we have to choose a value of r where the factor will be equals to 0, then we don't have to deal with that constant associated with it. So we can make, yeah, this equals to 0 by just substituting r equals to 0. And by doing that, a is gone, c is also gone, so you only have to solve for b. Okay, so you have b times 0 plus 1, that's 1, and 1 times 0 minus 1. So that's minus 1 times 1. You get minus b equals to 0 plus 3, which is 3. Then you get b is equals to negative 3. Okay. Next up, okay, we have this factor r plus 1. So we're going to make that 0. And in order to do that, we are going to substitute r equals to negative 1. Okay, so the a would be gone, b also, we have r plus 1, so we only have to deal with c. So c times negative 1, that's minus c. Negative 1 minus 1, that's negative 2. So minus c times negative 2, that is 2c. So this is going to be 2c equals to negative 1 plus 3. So that's just 2. And then divide both sides by 2, you're just going to get c equals to 1. Okay, and then finally, okay, we have r minus 1 remaining. So to make that 0, you have to make r equals to 1. Very simple. Oh, sorry. Okay, so b would be gone as well as c. So we only have a to solve. So a times r, so a times 1, that's just a. And then a times 1 plus 1, that's just 2. So 2a. 2a, no, and that would be equals to r plus 3, which is 1 plus 3, that is 4. And then a is going to be equals to 2. Okay, so we are done finding the constants and we can express our rational function, initial one, in partial fractions. So it's going to be 2 over r minus 1. B is minus 3. So you can put minus instead of plus, and then your numerator is still going to be positive. Minus 3r plus 3 over r plus c is 1 over r plus 1. Yeah, so I believe, yeah, this concludes the first part of this question. And now we're going to do a second part, which is to use the method of differences to find this summation. Okay, so yeah, they use the word hence. You definitely need to use this answer. So let's copy down the summation. R plus 3 over r cubed minus r equals to. Okay, so to use the method of differences, you have to use the decomposed form, the form that you use, the partial fractions form, and you just substitute the value of r, r equals 2, r equals 3, all the way to n. So let's start off with r equals 2. So 2 over 2 minus 1 minus 3 over 2 plus 1 over 2 plus 1, that's 3. So this one you can just write as 1. Okay, so that's for r equals 2. Now we are going to complete the next set. So you put the plus sign and write down your next set, which is r equals 3. So this is 2 over 3 minus 1, that's 2, minus 3 over 3, 3 over 3, plus 1 over 3 plus 1, just 1 over 4. Okay, so the idea is that you're supposed to look for common terms that always come in each set and cancel themselves out. Then you'll be left with one or two terms either at the very beginning and at the very end. Okay. All right. Yeah, I don't see any. Okay, let's continue. All right. So for r equals to 4, we have 2 over 4 minus 1. That's 2 over 3. Minus 3 over 4 plus 1 over 4 plus 1, which is 5. Okay. All right. So far, I can kind of see a pattern here. So, like for any three sets, the last term and the first term, so the last term of the first set and the first term of the last set, when you add them together, and then you add it with the second term of the middle set, they will cancel each other out. They'll cancel all of them out. Yeah. Yeah, so you can see 1 over 3 plus 2 over 3 is 3 over 3, then 3 over 3 minus 3 over 3. It just gets canceled out. Okay? Okay, let's see for this and this. Yep, they don't cancel each other out. Yeah, so does this, they don't cancel. Okay, let's see. Let's continue. Okay, for the next set, r equals to 5. So 2 over 5 minus 1, that's 2 over 4, minus 3 over 5 plus 1 over 6. So you can also see that in each set, the denominator actually increases by 1, whereas the numerators, they are just 2, 3, 1. Yeah. Okay, let's see if these three cancel. So 2 over 4 plus 1 over 4, 3 over 4 minus 3 over 4. Yep, they cancel. And yeah, I believe this pattern holds true. Now let's um, substitute the last two sets, which is r equals to n minus 1 and r equals to n. So plus n minus 1, 2 over n minus 1 minus 1, that's n minus 2, minus 3 over n minus 1, plus 1 over n minus 1 plus 1, that's just n, plus 2 over n minus 1 minus 3 over n plus 1 over n plus 1. Okay, so this is definitely going to cancel out. So is this, these two, they don't have the final term that will make them cancel out. So yeah, you can just leave them. And yeah, so our final answer would just be 2 over 1, which is just 2, minus 3 over 2, plus 2 over 2, which is just 1, uh, and plus 1 over 1 minus 3 over n, 1 over n minus 3 over n plus 1 over n plus 1. So this is, so 2 minus 3 over 2 plus 1. Yeah, that's 3 over 2. 1 minus n. So that's 1 minus 3 over n. So 1 minus 3. Yeah, that's just negative 2 over n plus 1 over n plus 1. So yeah, this would be a final answer. Yeah, it's right here. This will be the final answer for this part. Let's move on to the last part. Okay, so for the last part, we are just told to deduce the value of this summation where n is approaching infinity, as you can see by the infinity sign for the upper limit. Okay, so to do this question, very simple, you just take the limit as n approaches 0 for the summation result in terms of n. So it's 3 over 2 minus 2 over n plus 1 over n plus 1. So yeah, you just substitute infinity into the n. So infinity just means a really huge value. So when this n becomes really huge, this would just be equals to 0. And so this, therefore, the limit is just 3 over 2. So yeah, this would be final answer for the entire question. Let's move on to the next question. Okay, so for this second question, we are told that we're given a cubic equation as such, where B, C, and D are constants. So this cubic equation has roots alpha, beta, and gamma. And we are also told that, these equations are valid for alpha, beta, and gamma. So the sum of roots alpha plus beta plus gamma is equals to 2. And the sum of the root squares, aka we can write this as S2, is equals to 3, and S4 can also write as 5. Okay, so for the first part, we are told to find the values of B and C. Okay, so let's try to connect these equations to the coefficients B and C. Okay, so for B, the sum of roots, we can connect B to the sum of roots. Okay, so you must know this, minus B, the coefficient of the x squared term for cubic equation, over A, which is the coefficient of the x cubed term for cubic equation, is actually equal to the sum of roots. So in our case, just alpha plus beta plus gamma. And we're already given that it's equals to 2. So we can just write minus b is equals to 2. So therefore b would just be minus 2. Yeah, so we're done for b. Now we need to find c. Okay, let's do the same thing for c. We're going to connect c to an equation in terms of the sum of roots or root pairs or whatever. Okay, so for c, the formula is actually just c over a, which is the coefficient of x cubed. So that's just 1, is equals to the sum of alpha beta, sigma alpha beta. So sigma alpha beta, what that means is just the sum of root pairs. So alpha beta plus alpha gamma plus beta gamma. Okay. All right. However, we can see that there's no formula for the root pairs. So we need to somehow extract the expression for root pairs from one of the other two equations. And luckily for us, we can actually do that from the second equation, which is alpha squared plus beta squared plus gamma squared. Can generally write it as S2. This holds for all types of equation, cubic, quadratic, quartic. Okay, so S2 is always equals to sigma alpha, the sum of roots squared, minus 2 times sigma alpha beta, the sum of the root pairs. Okay, all right, so alpha squared plus beta squared gamma squared, that is 3. And sigma alpha, that's 2. So that's 2 square minus 2 sigma. Um, okay, this one we can just substitute c right away. So minus 2c equals to 3 minus 2 squared. That's just minus 1. And dividing both sides by negative 2, you would get c is equals to half. Okay, so yeah, we obtained our C and B. So yeah, this would be our final answers for the first part. Let's move on to the next part. Okay, so for the second part, we're told to find the value of D. Okay, so just like how we found the values of B and C, we're also going to apply the same method to find the value of D. So let's try to make an equation in terms of D as well as the roots. Okay. All right. So for D is the constant term in the cubic equation. So for D, so minus D over the coefficient of x cubed. So I hope you can see a pattern in here. So we always start with minus b, which is sigma alpha, and then c, positive c over a is sigma alpha beta. So d by right is going to be negative d over a equals to sigma alpha beta gamma. So for the case for a cubic equation, that is just the product of all roots, okay? So D is just alpha, beta, gamma. Minus D is equals to alpha, beta, gamma. So therefore D is just minus alpha, beta, gamma. Okay? All right, so to find alpha, beta, gamma in any of these equations, we have already used the second equation. We don't have such term, so we have no choice but to use the fourth equation. However, for the fourth equation, for S4, there is no general term. So we're going to have to use the we're going to have to substitute S4, S2 into the cubic equation. Okay? So yeah, don't worry, it's going to be very, very simple. Okay, so instead of x cubed, this becomes S3, x squared becomes S2, and so on. And the constant term, you just have to multiply it by 3. Okay, so let's do that. So S3 plus bx squared. So b is minus 2. So minus 2, x squared is S2, and plus cx. So c is half plus half. X is S1 and plus d. So d, like I said, you have to multiply it by 3 since we have 3 roots equals to 0. Okay, so our goal here is to find S3, which we can substitute into our next equation. I'm going to show it to you when the time comes, but let's just find S3 for now. So S3 minus 2. S2 is 3. Okay. And S1 is just the sum of roots, which is 2, and plus 3d. So let's just isolate S3. So S3 minus 6 plus 1, that is minus 5, plus 3d equals to 0. So S3 is just 5 minus 3d. So this is our first equation. Okay. So now our next step is to just multiply both sides of our cubic equation by x. So that would result in x to the power 4 plus b. Okay, b is minus 2, so minus 2x cubed plus half x squared plus dx. Yeah, so the constant term will become dx equals to 0. Okay, so we're going to now substitute the summations into each of the x terms. So x to the power 4 become S4 minus 2S3 plus half S2 plus DS1 equals to 0. So S4 we already know. S4 is just our very last equation. I already said it here. So S4 equals to 5 minus 2. S3 is 5 minus 3D plus half times S2. So S2 is 3. Then S1 is 2. So 2D. Yep, so equals to 0. So now you can see we have an equation only in terms of D. So let's solve this equation straight away. So 5 minus 10 plus 6D plus 3 over 2 plus 2D equals to 0. 6D plus 2D, that's 8D. Move everything else to the right-hand side. So you have 5 minus 10 plus 3 over 2 minus 7 over 2. So move it to the other side, you get 8D equals 7 over 2. And eventually you will get D is equals to 7 over 16. Yeah, so this would be a final answer for this part as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told that the sequence of positive numbers U1, U2, U3 such that U1 is less than 5, and for n more than or equals to 1, this is the case. So we are given the formula for UN plus 1 in terms of UN. Okay, and for the first part, we are told to consider 5 minus un plus 1. We need to prove by mathematical induction that this result is true. Un is less than 5 for all positive integers n. Okay, so I know that maybe some of you might be panicking when you see this question because you're so used to doing, summation proof by induction or divisibility tests or differentiation. Yeah, but the same general step-by-step process applies here. So your first step, as usual, is to let n equals to 1 and prove that this statement here is true for your base case. Sometimes it can also be n equals to 2, n equals to 3. So for that, please read the question carefully. Okay, so yeah, you can already just see U1. Yeah, we already told it's less than 5. So we can just write therefore case for n equals to 1 is true. Okay, and the next step is to write down our inductive statement, which is just as an assumption basically. So we can assume that U subscript K is less than 5. So it's basically taking your statement that's given in the question and replacing the n with K. So you assume that it is, true, that UK is less than 5, where K is a positive integer. Okay. And now this is where the main part comes. So now you have to let K equals to n plus 1. Okay. So 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 you just let un, okay? So now you solve for un, okay? So we already know that. So u 6 un plus 5 over un plus 2. So we're just taking the result that they gave us. And in the question, they told us to consider this. So we're also going to, make 5 minus un plus 1. So this is also just going to be 5 minus 6 un plus 5 over un plus 2. Okay, so now our goal is to combine this whole thing into a single fraction, okay, which we can, uh, confidently say is more than or equals to 0. Okay, so 5 minus 6 un plus 5 over un plus 2. So for 5, it's just going to be un plus 2 times 5 times un plus 2 minus 6 un plus 5 over un plus 2. Oh, I know it's going to be very easy to confuse. So this is not u subscript n plus 2, it's just u subscript n plus 2. Okay? All right. So 5 times un plus 5 times 2, that's 10 minus 6 u subscript n minus 5 over u subscript n plus 2. It's 5 u subscript n minus 6 u subscript n is minus u subscript n plus 5 minus plus 10 minus 5, that is plus 5 over u n plus 2. All right. So here, okay, so now we're going to somehow prove that this is more than or equals to 0. So in order to do that, um, let's factor out the negative 1 from the numerator for simplicity. So un minus 5 over un plus 2. Okay, so to make this simpler, we're going to split this up into partial fractions, but we're not going to do the normal method. We're just going to make the numerator un plus 2. And to keep the negative 5, we're just going to minus 7. Okay, so yeah, un minus 5 is equals to un plus 2 minus 7 over un plus 2. So this is minus un plus 2 over un plus 2 minus 7 over un plus 2. So this will just become 1, and you can multiply the negative 1 back. So you get 7 over un plus 2 minus 1. Okay. All right, let's see. Okay, so we know that un plus 2 is okay, let's see. All right, so we know that un or uk is less than 5. So un plus 2 is less than 5 plus 2, which is 7. And therefore 7 over un plus 2. So it's more than 1. So how we did this is you can reciprocate un plus 2. When you do it, you get 1 over un plus 2 more than 7. Wait, wait, no. 1 over un plus 2 is more than 1 over 7. And then you multiply both sides by 7, you get 7 over un plus 2 is more than 1. And then 7 over un plus 2 minus 1, you get more than 0. So, okay, you know what? I'll just keep this here. I'll do my conclusion in here. Okay, so we say that therefore, since 7 over un plus 2 minus 1 is more than 0, 5 minus un plus 1 is more than 0. So un plus 5 is less than 0, less than 5. Yeah, so like after some algebraic manipulation, you should be able to get this result. And therefore, you can write down your final statement. Hence, by principle of mathematical induction, u n minus u subscript n is less than 5 for all positive integers n. Yeah, so this would be a final answer for the first part. And this whole inequality thing, this whole working is optional. I just did it so that you can like see how to get the inequality that you require. You can also do it in your head if you want to. Okay, so yeah, with that, let's move on to the next part. Okay, so before I get started with this part, I realized I made a minor mistake in the previous part. It's just a sign error, okay, like a defining error. So this is actually I meant to write n equals to k plus one. So basically, all the n all the way to here is actually supposed to be all k. All right, yeah, it's a very minor mistake, but I still felt that I had to mention it. Yeah, so in the exam, please write down n equals to k plus 1. Okay? So, yeah, with that, we can start with this part. Okay, so for this part, we need to show that this statement is true for n more than or equals to 1. Okay, so to do this, yeah, let's just express un plus 1 in terms of un. So yeah, we're given this, right? So 6 un plus 5 over un plus 2. And now we're just going to find the difference between un plus 1 minus un. So 6 un plus 5 over un plus 2 minus un. So we're going to make the denominator for both terms the same. So 6 un plus 5 minus un times un plus 2. Okay, and then for this, should put more brackets in here because we didn't multiply the negative. Uh, yeah, so 6 un plus 5 minus un squared uh, minus 2un over un plus 2. So this is minus un squared, 6un minus 2un, that's plus 4un plus 5 over un plus 2. Okay, so let's factor out the negative 1 from the numerator. So minus un squared minus 4un minus 5 over un plus 2. Okay, let's try to factorize um the form. Okay. Okay, so factorizing the numerator, we get minus. So we get minus. Oh, sorry, it's still not working. So we get. Oh no. So I get my. Okay, give me a while. Okay, so sorry for the delay. So as I was saying, the factorized form is un minus 5 times un plus 1 over un plus 2. Okay, so all right, so let's try to prove that whether this is less than or more than 0. Okay, so um, as you know, this is definitely, yeah, so we proved in the previous part that un is less than 5. So this is definitely, uh, yeah, so un minus 5 is less than 0. So this is negative. Un plus 1, uh, un plus 1 is less than 6. All right, less than 6. And so this is less than 6. This is definitely negative. So these becomes positive, okay, less than 6, and then un plus 2 is less than 7, okay. Yes, so less than 7. Yeah, so I believe we can assume that, yeah, this can be more than 0, that this is positive, okay? Or you can, you do your long division to convince yourself, okay? Yeah, so therefore we can say that u subscript n minus un is more than 0, and un plus 1 is more than u subscript n, which is the result for n more than or equals to 1. Yeah, so this would be the final answer for this second part. So that's the entire question. Let's move on to the next question. Okay, so for this question, we are told to let K and M be non-zero constants, and we're given these three matrices A, B, and C. Okay, and for the first part, we're told to give full details of the geometrical transformation in the xy plane represented by the matrix B in each of the following cases. So first case is where M is equals to 1. So essentially matrix B is K0, 0, 1. Okay, so as you can see, these two elements in this diagonal are 0. So this is definitely not a shear. Otherwise, if these two, if any one of them was a non-zero term, the idea of a shear could be brought up. And then for the other diagonal, we can see that this is equals to 1. So that means y coordinate is fixed. So y coordinate not change, while the x coordinate is changing. So what is happening to the x coordinate? It's being multiplied by k. So therefore, we can say that this represents a stretch in the x direction. Scale factor k. Okay, right. Yeah, so that would be all for the first part. Now let's look at the second case, m equals to k. So that would look like k0, 0, k. So this is very similar to the first one, except that, diagonal here, both the y coordinate part, the bottom one, and the x coordinate part, it's both k. None of them are 1. So basically, both the x and y coordinates are being multiplied out by k. So we can say that this is basically a stretch, or we can say stretch in the x and y directions, both of which have scale factor k. So yeah, this would be our final answer for this first part. Let's move on to the next part. Okay, so before I get started with this next part, I realized I made a mistake in the first part for the part A, part 2, so m equals to k. So instead of saying stretch in both the x and y direction, you can just say it's an enlargement of scale factor k, okay? So yeah, this is an enlargement. And if you think about it visually, it does make sense because you are stretching in both the x and y directions. So essentially, you're just increasing the scale. You're just scaling up the shape, right? Or the points, right? Yeah, so this is an enlargement of scale vector A. Okay, so with that, we can start with part B. All right, so we need to show that matrix ABC is singular. So by singular, we should know that the determinant must be equals to 0. So we need to show that the determinant of matrix ABC is equals to 0. All right, so first we need to find out what ABC is. So to find the matrix ABC, we need to multiply matrix A and matrix B first to find matrix AB. So AB is A is 0, 1, -1, 1, 1, and 1. And B is K 0, 0, M. Okay, so to multiply matrices like these, you first take the number of rows and columns. So for A, it's a 3 by 2 matrix, and for B, it's a 2 by 2 matrix. So you can see, to know whether you can multiply two matrices, you need to see whether the number of columns for the first matrix numbers matches the number of rows of the second matrix. So in this case, they do. So the dimensions of our resultant matrix would be a 3 by 2. So AB would be a 3 by 2 matrix. So AB will have 3 rows and 2 columns. I believe this space should be enough. Okay, so 3 by 2. So we have the first row first. So it's a 3 by 2. So 1, 2, 3, 1, 2. Okay, so this element, first row, first column, we want to find this first row, first column. So first row, first column. So 0 times k times 1 times 0, that is 0. And 0 times 0 times 1 times m. So 0 plus m, that's just m. And then for this, same thing, minus 1 times k plus 1 times 0. So that's minus k. And then minus 1 times 0 plus 1 times m. So that's m. And for here, we have 1 times k plus 1 times 0. So just k and 1 times 0 plus 1 times m. Yeah. So yeah, this is our matrix AB. Now we can find matrix ABC by multiplying our resultant matrix AB. So 0 m minus k times m, k times m with a matrix C, just 2, -1, 1, 1, 1, 2, 1, 1, 2. So let's first figure out what dimensions our matrix ABC has. So how many rows and how many columns. So a matrix AB, it's a 3 by 2. And matrix C, it's a 2 by 3. So yeah, these two numbers match. So this is just going to be a square matrix of 3 by 3. So 3 rows and 3 columns. Okay, so first element would be the first row, first column. So first row, first column. So 0 times 2 plus m times 1, that is just m. And then 0, and then first row, second column. So this one right here. So 0 times -1 plus m times 1, that's just m. And then 0 times 1 plus m times 2. So that's 2m. Okay, and then the second row multiplied by the first row. So it's all here. So minus k times 2. So minus 2k plus m times 1. So that's m minus 2k. And then we have minus k times -1, that is k. plus m times 1, which is m. So that's just m plus k. And then here minus k times 1, that's minus k plus m times 2, so 2m minus k. Okay, you know what? I believe I need more space. I'll just extend it here. All right, and then the third row, first column. So k times 2, k times 2 is 2k plus m times 1. So 2k plus m. Same for this k times -1, that's negative k plus m times 1, so m minus k. And then k times 1 plus 2m. So k plus 2m. Yeah. Yeah, so this is our matrix ABC. Okay, now we're ready to find the determinant. All right, so to find the determinant, you know what? Let's just copy down matrix ABC. So m, m, 2m, m minus 2k, m plus k, 2m minus k, 2k plus m, m minus k, k plus 2m. All right, so let's find the determinant. So to get the determinant, you start off with the first row and take the uh, element in the first column, so m. And then you cover up these two rows. You take the determinant of the remaining elements. So m times m plus k times 2m minus k, m minus k, k plus 2m. Okay, so you repeat it for the second element in the second column, first or second column. So minus this element. So cover the rows and elements associated with it and take m minus 2k, 2m minus k, 2k plus m, k plus 2m. Okay, yeah, so this is it. And take this. So this is going to be plus 2m. Take the determinant of the remaining elements, m minus 2k plus m plus k times 2a plus m times m minus k. Yeah, so this is the determinant of ABC. All right. Okay, so m times the determinant of this, take the cross multiply these. So m plus k times k plus 2m minus these two, m minus k times 2m minus k minus m times these two. So m minus 2k times k plus 2m minus these two, 2m minus k times 2k plus m, and then plus 2m times these two. So m minus 2k times m minus k minus these two, m plus k times 2k plus m. Okay, so now let's expand and simplify this whole expression. That's going to take a lot of space. So m times mk, mk plus k squared times 2mk m times k plus 2m squared plus 2m squared plus k squared times 2mk minus uh, m times 2m, so 2m squared minus k times 2m, so minus 2mk, so minus 2mk minus mk, so that is minus 3mk plus k squared. And then minus m. So this one, yeah, same thing. I believe, let's find the k squared term. So that's minus 2k squared, and then the mk term. So minus 2k times 2m. So that is minus 4mk plus m times k. So minus 4mk plus mk. So that is minus 3mk. And then m squared is m times 2m. So plus 2m squared minus this. So this is, as you can see, is in the form a minus b times a plus b. So you can just write as 2m squared squared. So minus 4m squared minus km or mk. Yeah, right, mk. But since there's a negative sign outside, this will become a positive, right? Then plus 2m. Okay, let's do the same for this. So minus 2k times negative k, that is 2k squared. And then the mk term, so minus 2k times m, so minus 2mk minus mk. So that's minus 3mk. And then m squared is m times m, so plus m squared. Yeah. Yep. Okay. Yep. Yeah. And then for this minus the k squared term, 2k times k, that is minus 2k squared. And then the mk term, so you have km as well as 2 km. So km plus 2 km, that is plus 3 km, but since there's negative sign, it's going to be minus 3mk, and then the m squared term, so m times m, so m squared, negative sign, so minus m squared. Okay, let's simplify everything inside the brackets, and then we'll add the m's. Okay, so okay, so this is minus plus uh wait, oh yeah, that's yeah, that's minus, yeah, okay. So k squared first, so k squared minus k squared. So I believe these would cancel out. So 2mk plus mk. Uh the yeah, okay, so 2mk plus mk plus 3mk. Oh, and 2m, okay, cancels out. So yeah, we only have the mk terms, so 6mk. And then we have minus m times okay, the k squared terms, yeah, this is the only one. minus 2k squared. And then mk, we have minus 3mk plus mk. Wait, wait. It's supposed to, wait, oh, I believe wait, what did, wait, no. Did I do? Oh, I think I might have expanded that wrongly. Oh, yep, I believe I did. Shoot. Okay. As you can see, this question is pretty tedious because of all the algebra, but it's okay. So yeah, the k squared term is minus 2 k squared. So it's just minus 2 k. Wait, is it minus 2k squared? Wait, oh yeah, it is. It is minus 2k squared, but since there's negative sign outside, this was positive. And for the mk term, we have minus mk uh, plus 4mk. So 4mk minus mk, that is 3mk. So minus that, you get minus 3mk. And then m squared is 2m plus m, so 2m squared. Minus that, you get minus 2m squared. Yeah. Yep, I believe that's it. Yeah. All right, so here we can see the 2m squares cancel out, as well as the 2k squares. So we only have minus 3mk, minus 3mk, which is minus 6mk. All right, and then for the last one, 2k squares cancel out, as well as the m squares. So we only have minus 3mk, minus 3mk. So this is plus 2m minus 6mk. Okay, so you have 6m square k uh, plus 6m square k minus 12m square k. So this is equals to 0. So yeah, we just proved that the determinant is 0, so we can write since determinant ABC is equals to 0, uh, ABC is singular. Sure. Since the start of the question says show that. So yeah, this would be a final answer for this entire question. Let's move on to the next question. Okay, so for this question, we're told that oh, sorry. Oh, goodness. Shoot. Okay, yeah, so we're told that the curve C has this polar equation r squared equals to tangent to theta, where theta is between 0 and pi over 8 inclusive. So we need to sketch C for the first part and to state the greatest distance of a point on C from the pole. So basically, we need to find the greatest value of R. Okay, so to sketch any polar curve, you start off by drawing the initial line theta equals to 0, which is equivalent to the x-axis. And you do a table of values for every value of theta from 0 to pi over 8, and you write down the corresponding value of R. So you don't have to do a table of values if you are okay with just typing it into a calculator and taking a mental note of the values. So when you substitute 0, you get 0. So that means it starts from the pole, and then you slowly increase it to pi over 8. So you can do like pi over 12, you will get 0.7598. And then you can also do pi over 14. Pi over 10. Yeah, 0.852. So you can see it's increasing as the angle increases, and eventually when you substitute pi over 8, which is the greatest value, you're going to get 1. So yeah, the value of r varies from 0 to 1, and it increases as the angle increases. So yeah, so the pi over 8 is like half of 45, so 45 is around here. So pi over 8 should be here. So you can draw like this. Yeah. So this is the curve C. Sorry, yeah, this is the curve C. Yeah. And now we need to state the greatest distance of the point from the pole. So that's basically the greatest value of R. And as we saw just now, when we're sketching C, the value of R increases with the value of theta. So intuitively, the greatest distance has to be when theta is equals to pi over 8. And that would give us R equals to 1 as the greatest distance. So yeah, this would be our final answer for the first part. Let's move on to the next part. Okay, so for this part, we're told to find the exact value of the area of the region bounded by C and the half line theta equals to pi over 8. So half line theta equals to pi over 8. I'll just make a quick sketch. Uh it's basically so basically the half line. It's basically a straight line originating from the pole, and it makes an angle of theta equals to pi over 8 with the initial line. So I'm just going to draw a dashed line to show you. So yeah, this is the half line theta equals to pi over 8. So we need to find the area between this dotted line as well as the curve C. Okay, so to find the area bounded by polar curves and half lines, can use this formula, half integral of r squared d theta. And you have to put in your limits, which includes the maximum half line, pi over 8, as well as the pole, or wherever your curve starts. So for our case, our curve starts at the pole, so the lower limit is going to be 0. So upper limit is pi over 8, lower limit is 0. Okay, so now we're ready to integrate. So r squared, we're already given the exact value, tangent to theta, d theta. Okay, and to integrate tangent theta, you can just express tangent to theta as negative sine 2 theta over cosine 2 theta. I mean negative sine 2 theta, because there's no negative sign in the tangent to theta. So that extra negative sign, you can take it out of the integral and express it like this instead. The reason we do this is because it is much easier to integrate it this way. Okay? Yeah, so integrating this, you should realize that it's in the form of f prime x in the numerator over fx. So fx is cos 2 theta. Yeah, I don't think it's still in the form, but it's almost there. Okay, so I over 8, 0. So f prime x is just minus 2 sine 2 theta over cosine 2 theta d theta. Yeah, so now it's in the form f prime x over fx. So this just but then the 2 is there. So we have to cancel this 2 out by adding half outside again. So it's minus 1 over 4 integral of this. And integrating this, you get ln cosine 2 theta pi over 8 and 0. So this is minus 1 over 4 ln cosine 2 times power of 4, that is pi at 2 times power of 8, that's power of 4, minus ln cosine 2 times 0. So that's just ln 0. And this is equals to, so ln cosine pi over 4, cosine pi over 4 is just 1. Oops, sorry. Yeah, cosine pi over 4 is ln 2 over 2. Ln 0 is just, ln cosine 0. Cosine 0 is 1, so ln 1 is just 0. So this is just 1 minus 4 times ln cosine pi over 4. So 1 minus 4 times ln cosine pi over 4, which is square root 2 over 2. And to get rid of the negative sign, since there's a ln in here, you can use the power rule and then make this square root 2 over 2 to the power of negative 1. Then you get 1 over 4 ln 2 over square root 2, which is just square root 2. Okay, they didn't really say what you have to do. Yeah, and you can also remove the half power over to there, and this would be 1 over 8 ln 2. Yeah, so you can leave these two as your final answers, either one of them. And yeah, with that, let's move on to the next part. Okay, so for this part, we need to show that C has a Cartesian equation, this, and we also need to find the domain of X and Y. All right, so to convert a polar equation into a Cartesian equation, we need to know these formulas. So first one is x squared plus y squared equals to r squared. And we also need to know that x is just r cosine theta. Let me take it off. Yeah, so x is r cosine theta and y is r sine theta. Okay, so let's copy down our polar equation. That is r squared equals to tangent to theta. Now, tangent to theta doesn't appear in any of our equations that we mentioned, so we have to express tangent to theta in terms of sine and cosine first, or tangent, which if you do, you would get y over x equals to tangent theta. Yeah, so r squared, that's x squared plus y squared. And tangent to theta, to change it to tangent, just go to MF19 under trigo. Oh wait, trigonometry. Yeah, so tangent to A is this whole thing, 2 tangent A over 1 minus tangent square A. So this is 2 tangent theta over 1 minus tangent square theta. Okay, so this is x squared plus y squared, and 2 tangent theta, that is 2y over x. And then 1 minus tangent square theta is 1 minus tangent square. Tangent square is y squared over x squared. Yeah, so let's multiply both sides by this. Okay, so this would be x squared plus y squared times 1 minus y squared over x squared equals to 2y over x. Okay, you know what? Let's also multiply the x. Yeah, but we're going to expand the x later. We'll just keep it alone for now. Okay, so multiply everything, expand these two. So you get x squared minus y squared plus y squared minus y over 4, y to the power 4 over x squared equals to 2y. Okay. Okay, so multiply everything by x on the left hand side, so you get x uh cubed. Wait, yeah, x cubed, I believe. Yep. Yeah, you get x cubed minus x y squared plus wait, what y squared? Wait a minute. Okay, yeah, the y squares cancel out. So x cubed minus y over 4 over x. Yeah, so x over x squared, yeah, that's just 1 over x equals to 2y. So now multiply both sides by x to get rid of the denominator. So you get x to the power 4 minus y to the power 4 minus 2xy. I just multiplied by x on here and then did immediately to the right hand side. And so this would give you your final answer, x to the power 4 minus 2xy minus y to the power 4 equals to 0. So shown. But we're not done here yet. We also have to convert our range, our domain for theta in here into x and y. So it's very simple. So yeah, you can just write down your domain for theta. So for x, it's going to be r cosine theta. So r is wait a minute. uh, r square is wait, r is just square root tangent 2 theta. So square root tangent 2 times pi over 8 cosine pi over 8. And then you have square root tangent 2 times 0 cosine 0. So tangent 2 times 0 is just 0. So this is just 0 and then x. So square root of tangent 2 times pi over 8 is 1. So it's just 1 times cosine of pi over 8. So that's also shown. Now let's do for y. Okay, so y is so r is tangent 2 times pi over 8 times sine pi over 8 times tangent 2 times 0 sine 0. So this is just between 0 and sine pi over 8. Yeah. So yeah, this would be our final answers for this entire part. Let's move on to the last part. Okay, so for this last part, we are told to use our answer in B. We need to deduce the exact value of the area bounded by C, the x-axis, and the line x equals to cosine pi over 8. Okay, so let's see what they mean by that by doing a little sketch on our C, on our sketch of C. Okay, so I'm going to be using black for this. So x equals to pi over 8 is right here. X equals to cosine pi over 8 is right here. Yeah, because if you substitute x equals to r cos theta, and you equate it to cosine pi over 8. And then theta is pi over 8. Yeah, you'll get r equals to 1. And this is the point where our distance from the pole is equals to 1. Okay? So yeah, the length of a base of the triangle would be cosine pi over 8. Okay, so to find the area that they want, we can see that we have a little triangle in here. And we already know the area of the shaded region, which we found in part B. So we need to find the area of the triangle and then subtract the area of the shaded region. Okay, so this is cosine pi over 8, and this is we're using the Pythagoras theorem. Yeah, this is just y equals to square root of 1 minus cos square pi over 8. This looks very similar to our identity cos square plus sine square equals to 1. So it's just a square root of sine square pi over 8. So in the end, it's just sine pi over 8. Yeah, so with that, we're ready to do this question. So this is half times the base cosine pi over 8 times height sine pi, my goodness, pi minus the answer to part B, which is the area bounded by the half line as well as the curve. So that's 1 over 8 ln 2. Yeah, so to find the exact value of this, you can see that it's very similar to the double angle formula for sine. So we're just going to make it in that form. Okay, so this is half times half. Since we don't have the 2, so and we have to put the 2 for the double angle formula. So half times 2 cosine pi over 8 sine pi over 8 minus 1 over 8 ln 2. So this is in the form of 2 cos theta sine theta. So yeah, you can see a sine 2a is equals to 2 sine a cosine a. So this is 1 over 4 uh, sine 2 times pi over 8 minus 1 over 8 ln 2. So we know what sine 2 times pi over 8 is. It's just sine pi over 4. And that is 1 over 4 times square root 2 over 2 minus 1 over 8 ln 2. So this is square root 2 over 8 minus 1 over 8 ln 2. So yeah, this would be a final answer for this entire question. So it's the entire part, the last part, so it's the entire question. Let's move on to the next question. Okay, so for this question, we're told that the plane pi has this Cartesian equation. And for the first part, we're told to find the perpendicular distance from the origin to the plane pi. Okay, so to do this question, yeah, you can see they gave us very little space. So I'm going to show you the way to do it by drawing a diagram. So this is our plane, and this is the origin O, which is 0, 0, 0, 0. And this is the normal to the plane, or yeah. And then this is the foot of the perpendicular. So the perpendicular distance would be the length of this vector that's normal to the plane. So this vector is gonna have the same direction vector as the normal vector, and yeah, so it's gonna be something like the a position vector. So the vector equation of this line is going to be a position vector on this line. So we can take the origin as such. So it's the origin plus a scalar times the uh, direction vector of the normal vector. So this it could be something like this: k times 1, 3, 2. That's the direction vector of the normal vector. You can get it from the coefficients of x, y, and z. This um, has to be. So what we want to find is the foot of the perpendicular. Okay. Or we just want to find the equation of this line. Okay. There's k, 3k, 2k. So substituting this into the plane equation, since we want to find the foot of the perpendicular, which exists both on this line as well as the plane. So it's k plus 3 times 3k, 9k, plus 2 times 2k, that's 4. 4k equals to 1. And then k would be equals to 13 and 14k, so k is 1 over 14. Yeah, so therefore, the vector that we're interested in, the vector which we're interested in is k 1 over 14 times 1, 3, 2, or 1 over 14, 3 over 14, and 2 over 14, which is 1 over 7. So perpendicular distance, just take the modulus of this whole vector. So 1 over 14 square plus 3 over 14 squared plus 1 over 7 squared. So I get 1 over 14 squared plus 3 over 14 squared plus 1 over 7 squared. And you would get square root 14 over 4 units as your final answer. So yeah, this would be our final answer for the first part. Even though it's only 2 marks, it's a lot of working. Yeah, I just showed you like the way how to do it. So you need to find the vector, this vector, okay, which is just k, and then you need to find the value of k. Yeah, and then you find the vector, take the modulus of the vector. Okay, so yeah, with that we can move on to part B. Okay, so for this second part, we're told that relative to O, the points A, B, and C, they have these position vectors respectively. And we're told to find the acute angle between the planes OAB and pi. All right, so to do this, we need to first find the normal vector to plane OAB. For pi, we already know it's basically 1, 3, 2. All right, so to find that, we have to take 2 direction vectors along plane OAB. So that could be um, the so that could be okay. So this is O, this is A, this is B. So from O, we have the direction vectors OA and OB. So the normal vector is going to be perpendicular to both of them. Okay, so yeah, let's find the normal vector to OA and OB. Okay, so normal OAB equals to I J K of OA. So OA is minus j plus 2. Okay, so it's 0, minus 1, and 2. And OB is 2i minus k, so 2, 0, minus 1. Okay, so I'm just gonna use calculator to find this. But if you don't have the calculator means to do, so you just do it the same way you find the determinant of a 3 by 3 matrix. So you would log the I, take the determinant minus j. So 0, 2, 2, negative 1. So you take that and you do the same for k, 0, negative 1, 2, 0. And or you can do it in your calculator as well. So define 3-dimension 2, 0, negative 1. So vector A times vector B, you would get 1, 4, 2 as the normal vector. Yeah, so for reference, let's also write the normal vector of pi, which is 1, 3, 2. 1, 3, 2. And so now let's find the acute angle. So to find the acute angle, let's draw a sketch of the planes. So this is pi, this is OAB. These are the normal planes to each other. Okay, so this is the angle that we're interested in finding between them. So this can either be obtuse or acute. If it's acute, we just find that angle. If not, we take that angle and subtract 180 degrees to find this angle. If this is obtuse. So these angles are 90 degrees, and this the angle that is made by the planes. Okay, so let's start out by finding the angle between the planes. I mean the angle made between the normal of the planes. Okay, so we can use the scalar product. So normal of OAB dotted with the normal of pi is equals to the modulus of both normals, the product of both moduluses of both moduli times the cosine of the angle. Just gonna call it theta for now. So cosine theta. So 1, 4, 2 dotted with 1, 3, 2 divided by the modulus of the OAB. Oh, yeah, so that's 1 square plus 4 square plus 2 square times 1 square plus 3 square plus 2 square. So 1 plus 9, that's 10. 10 plus 4 is 14. So 1 plus 12 plus 4, that's 17 over square root of, oh my, okay, never mind. Square root of 1 square plus 4 square plus 2 square, that's 21. So 21 times 4 is square root 294, which is 7 square root 6. Oh, sorry. Yeah. So this is theta. Yeah, I hope this is an acute angle. All right, so to find this, so since these two are 90 degrees, the sum of these two angles has to be 180. So to find acute angle, wait, never mind. I think I should just leave it. I should not label it. Could be an obtuse angle. You may never know. Yeah, I feel like this is going to be an obtuse angle since the value for cosine theta in here is positive. Yeah, so the acute angle is probably this. So acute angle is 180 degrees minus this angle, which is also 180 degrees minus cosine inverse 17 over 7 square root 6. So that's just cosine inverse 17 over 7 square root 6. So in degrees, that is 7.5 degrees to one decimal place. So yeah, this would be our final answer for this part. Let's move on to the next part. Okay, so for this last part, we are told to find an equation for the common perpendicular to the lines OC and AB. All right, so to understand how the common perpendicular looks like and to, find the equation, let's draw a diagram. So this is OC, this is OAB. So the common perpendicular has to be perpendicular to both OC and AB. Okay. So we're going to let this point along OC be P and this point along AB be Q. Right. So let's start off by finding the vectors OC and AB first. So OC, I believe we already given that. The OC is just this 2i minus j minus k. So that's 2i minus j, so minus 1 minus k. So 2 minus 1 minus 1. And we also have to find the vector AB. So to find vector AB, just take OB minus OA. So OB is this 2i minus k. So 2i, so 2, 0 minus 1. So 2, 0 minus 1, and then minus OA. So OA, I believe, is 0 minus 1, 2, minus j plus 2k. So 0 minus 1, 2. Yeah. And this is 2 minus 0 is 2. 0 minus negative 1 is 1. And minus 1 minus 2 is minus 3. Okay. Yeah, so this is AB. Okay. Now we're going to find the position vectors of P and Q. Okay, so let's find position vector of OP. So OP is just a general point. Could be any point along OC. So we're just going to write down the vector equation of OC. So O, which is the origin, so this is 0, plus the direction vector times the scalar. So the scalar, we're just going to let it be t, and the scalar is just going to be OC. So 2t times 2 minus 1 minus 1. So it's going to be 2t minus t minus t. Okay, and then for OQ is just OA. Yeah, again, this is the vector equation of AB. So it's OA. So it's 0 minus 1, 2. 0 minus 1, 2 plus S times AB. So S times 2, 1, negative 3 equals to 2S, S minus 1, 2 minus 3S. Okay, and now let's find PQ. So PQ is just OQ minus OP. So OQ is 2S. OP is 2T, so 2S minus 2T. S minus 1 minus negative T, so plus T. OQ is 2 minus 3S minus negative T, so plus T. Okay. Yeah, so this is PQ. So yeah, so this is PQ. Yeah, now we're going to take the dot product with PQ and AB. So we're going to equate it to 0 since they have to be perpendicular. So 2S minus 2T, S plus T minus 1, T minus 3S plus 2 dotted with AB. So 2, 1, negative 2, 1, negative 3 equals to 0. Oh no. What the heck? Okay. So 4S minus 4T plus S plus T minus 1 minus 3T plus 9S minus 6 goes to 0. So 4 plus 1 plus 9, that is 14S minus 4T plus T minus minus 3. So that's minus 6T. That's equals to negative 1 minus 6. That is negative 7. So yeah, this equals to 7. So this is the first equation. Yeah, let's do the same for PQ and OC. So PQ and OC, so 2S plus 2T, S plus T minus 1, T minus 3S plus 2 dotted with OC is 2, negative 1, negative 1 equals to 0. So this is 4S minus 4T minus S minus T plus 1 minus T plus 3S minus 2 equals to 0. So for the S, we have 4S minus S plus 3S. So we have 6S. And then for T, we have minus 4T minus T minus T. That's minus 6T equals to 1 minus 2. So that's 1. Yeah, and then yeah, so this is equation number 2. So as you can see in both equation 1 and 2 have negative 6. So we can eliminate that from both equations by subtracting them together. So yeah, we have 14S minus 6S. That is equals to 7 minus 1, which is 6. And yeah, then S would just be, so we either have to find S only or T only, then we can, oh wait, never mind, we have to find both. Yeah, because we're going to take the distance of PQ. Yeah, so we're going to have to find both. So 6 divided by 8 is 3/4. And then we'll just substitute it back. So 6 times 3/4 minus 6T equals to 1. And 6T would just be 6 times 3 over 4 minus 1. So that's 7 over 2. And then t will just be 7 over 2 divided by 6. That is 7 over 12. All right. Yeah, so you can just substitute it straight into the equation for PQ. Yeah, I'm not gonna explain much further. I'm just gonna straight away substitute to that. So 2s minus 2t is 1 over 3. Then st plus 1. So s is 3 over 4 plus 7 over 12 minus 1. Okay, again, it's 1 over 3. And then t minus 3s, so 7 over 12 minus 3 times 3 over 4 plus 2. That's 1 over 3. You need a point that lies along the common perpendicular, aka PQ, so we can take OPS that point. And you need the direction vector, the general direction vector along PQ. So it doesn't have to be 1 over 3, 1 over 3, 1 over 3. You can simplify it to just 1, 1, 1. So therefore, the vector equation is just going to be OP. So OP, oh, I didn't find OP. That's okay. OP is pretty simple. Just so T is 7 over 12. So 7 over 12 times 2T, that's 7 over 6 minus T is 7 over 12 minus T is also 7 over 12. Yeah, so you can factor out the 12. Then you would get a 14 minus, or you can factor out 7 over 12. Then you would get 2, negative 1, negative 1. So yeah, this is going to be 7 over 12 times 2, negative 1, negative 1. 2, negative 1, negative 1 plus a scalar multiple times 1, 1, 1. So yeah, this would be our final answer for this last part as well as the entire question. Let's move on to the final question. Okay, so for this last question, we are given a curve C that has this rational equation. So curve C is a rational function. And yeah, for the first part, we're told to find the equations of the asymptotes of C. All right, so to do that, let's equate the denominator x plus 1 to 0. And by doing that and solving for x, you will get the vertical asymptote, which is x equals to negative 1. So that's our first answer. And now we need to find our horizontal slash oblique asymptote. So if, as you can see here, the numerator actually has a greater degree of 2 than the denominator, which has a degree of 1. So if that's the case, then we would have an oblique asymptote. So to get that oblique asymptote, we have to do long division in here. So we need to divide x squared plus x plus 1 with x plus 1. Okay, so multiply by x, so x squared plus x. So you would get this is just x, and then this is 0 and then 1. So doing this, you get y is equals to x plus 1 over x plus 1. And then you take the limit as x approaches to infinity. You will get y equals to x as your oblique asymptote. So yeah, these would be our final answers for the first part. Let's move on to the next part. Okay, so for this part, we're told to find the coordinates of any stationary points on C. Okay, so first of all, we obviously have to find dy dx, and we need to equate it to 0. So first, let's write down an equation in terms of y. So let's take this form. It'll be easier to differentiate. So x plus, instead of 1 over x plus 1, just going to write x plus 1 to the power of negative 1. And now we're going to differentiate it. So differentiate the x, we get 1, and then differentiate x plus 1 to the power of negative 1. You bring down the power, so minus and x plus 1 to the power of minus 1 and minus 1. So minus x plus 1 to the power of negative 2 divided by the derivative of the inner function, which is just 1. So this is just 1 minus 1 over x plus 1 squared. So equate dy dx to 0. So this is 1 over x plus 1 squared equals to 1. And this is x plus 1 squared equals to 1. Then you would get x plus 1 equals to 1 and x plus 1 equals to negative 1. Yeah, so this is going to be x equals to 0 and x equals to negative 2. But they ask for the coordinates, so we also have to find the corresponding y values as well. So y is going to be 0 plus 1 over 0 plus 1. So that's just 1. And this is going to be negative 2 plus 1 over negative 2 plus 1. So this is going to be negative 2 plus 1 over negative 1. That is negative 3. Yeah, so our coordinates are going to be 0, 1, and negative 2, negative 3. So yeah, this would be a final answer for this part. Let's move on to the next part. Okay, so now we just have to sketch C. Okay, so to sketch any rational function, okay, we first start off by drawing our x and y axes. Try to use the whole space provided. So this is the x-axis, this is the y-axis, and draw your asymptotes first. So we have x equals to negative 1, which is the vertical asymptote. It's just going to be a vertical line since there's only x. So this is x equals negative 1. And then we have to draw oblique asymptote y equals to x. So that's going to look something like this. And so this is y equals to x. Yeah. Okay. Now the next step is to uh, label any intersection points with the axes, so the x and y intercepts. So to find the y-intercepts, just substitute x equals to 0, and you would get you know, a 1 as your y-intercept. So this is 1. This is the y-intercept. And after that, you can find your x in y your x-intercept, sorry, um, by taking the value Okay, yeah, let me take the value. So x plus 1 over x plus 1, now equate it to 0, and get x times x plus 1 equals to 0. So this is x squared plus x plus 1 equals to 0. So now yeah, we're going to have to see if this equation has any real solutions or not. And no, it doesn't have any real solutions. So there's no x-intercepts, okay? So therefore, um, our curve is only going to be here and here. So like it's going to be in these branches, okay? And you also have to take the minimum points into account. So for here, the minimum point is actually the y-intercept. So that's going to be the turning point. Okay, you know what? To kind of redo that. Yeah, so this is this for this branch, and then for this is -2, -3. So -2 is around here, and then this is -3. Yeah, so it's around where I drew this dot. Okay. Yeah, so this is the other branch. And since there are no x intercepts, yeah, so this is going to be our final answer for this part. Let's move on to the next part. Okay, so for this part, we need to sketch the curve with this equation. So the only difference between the curve C, like the equation of the curve C and this, is that all the x's are absolutes, okay? So yeah, all the x's, they can only be positive now. And so what that means is even for the negative values of x to the left of the y-axis, it's going to take the same y values as the corresponding x values to the right-hand side. Okay, so basically you just take everything to here and you reflect it on the opposite side along the y-axis. Okay, so it's kind of like what you do with your modulus curves, like when the whole equation is made into a modulus function, except that you reflect it over the y-axis. So let's do that. So this is the x-axis, the y-axis. This is our asymptotes. Yeah. So yeah, it looks like this. Yeah, so this is one. And now we're going to reflect everything to this side over to the other side. So it's going to look exactly the same. Yeah, that looks just about right. Yeah, so this is our curve. And don't forget to label any critical points. In this case, this is the only critical point that we have here. So yeah, with that, let's move on to the final part. Okay, so for this final part, we need to find in exact form the set of values of x for which the previous curve in the previous part is less than 3. So for these types of questions, you first have to, remove the inequality sign and replace it with the equals sign. Okay, so let's start. So you equate it to 3. Yeah, and then yeah, as you can see, we don't really want to deal with this modulus. So I believe we're just going to make a substitution. We're going to let u equals to the modulus of x. So now this is a normal quadratic equation. So this u squared plus u plus 1 equals to 3u plus 3. So this is going to be u squared minus 2u minus 2 equals to 0. Let's try factorizing this. I don't know if it'll work. Okay, unfortunately, it doesn't. So we're going to have to use the quadratic formula. So minus b, so minus 2, minus negative 2 plus or minus square root of b squared, so minus 2 squared, minus 4a, which is 1, and c, which is negative 2, over 2 times a, or 2 times 1. So using this, you're going to get 1 plus 3. And 1 minus 3, 1 minus square root 3. And since, okay, and now let's substitute back the modulus x. So I have a feeling that one of the values we'll have to reject because it's negative, and modulus of x cannot be negative. Yeah, so yeah, it's this one. So yeah, this is rejected. Therefore, for x, we have two possible values, 1 plus square root 3 and negative 1 times 1 plus square root 0, negative 1, negative square root 3. So yeah, these are our critical points that we need to write our inequalities with respect to. Yeah, so now our next step would be to make a little sketch in the curve that we drew in the previous part. So you can see that 3 is probably around here. So this is the line y equals 3, and these are the two intersection points that we found. And they told us to find the set of values for which this curve is less than 3. So everything below y equals to 3. Yeah, so yeah, everything that is below, which is basically everything between the two critical points. Therefore, we can say that x is basically between negative 1, negative square root 3, and 1 plus square root 3 without the equal sign, because there's no equal sign in the inequality that we're given at the start of the question. So this would be our final answer for this part as well as the entire question. And we have also come to the end of this paper. So I hope you found this video helpful in preparation for your exams and whatnot. And if you did find it helpful, please make sure to like and subscribe to this channel for more videos like this regarding past papers, solving videos of A-level maths and further maths. And if you are interested in tutoring services, I do offer tutoring services one-to-one for A-level maths and A-level further maths. For A-level maths, it's paper 5 and paper 4, paper 1 and paper 3. Yeah, so please leave any feedback or any questions that you have in the comments down below. And yeah, with that, I'll see you guys again next time. Okay, thank you.